Hi, this is Ms. Delosier, and these are the notes on relative velocity. This is just a review. Relative velocity has to do with your frame of reference, and a frame of reference is simply a fixed point that you are going to compare a moving object's position to. And that's all review. That's all from the original set of notes on motion. So let's look at this example where the object doesn't actually have to be moving. So let's look at two moving objects. Let's look at two cars, the blue car A and the orange car B. In this example, the blue car is going to be going 55 miles per hour and the orange car is going to be going 65 miles per hour. Now, if you're in the blue car, then you would be able to say that the orange car, car B, is going faster than you. It's going faster than 55 miles per hour because it's going to pass you. Whereas if you're in the orange car, you would be able to say that the blue car was going slower than you because it's going to be headed, you're going to pass it and it's going to be in your rear view. So there you can see that you can have a frame of reference that is actually moving. And we're going to look at a more complicated example of that. So let's look at having stairs, and let's say that I'm going up the stairs at a speed of 1 meter per second. So this is actually an escalator. So if I'm standing still on an escalator at 0 meters per second, and my frame of reference is the ground of like the mall, then I'm going to be moving at a relative velocity of 1 meter per second. Because if the ground is standing still and I'm standing on the escalator, I'm moving at 1 meter per second. But what happens if I'm actually moving? So what happens if my frame of reference is the escalator itself? So if I'm standing on the escalator and I'm moving at 1 meter per second on the escalator, but my frame of reference is the escalator. So picture this in your head. You're standing on the escalator. Does it really feel like the escalator's moving underneath you? I mean, you're moving at 1 meter per second, the escalator's moving at 1 meter per second. So with reference to the escalator, you're actually not moving, you're standing still. So all that means is with reference to the escalator, you're standing still on the escalator. With reference to the ground, you're moving away from the ground at 1 meter per second. I hope that makes sense. So let me rephrase it. If I'm standing on a moving object, and I'm just standing there and I look at a point off to the side, I can tell that I'm moving. But if I'm standing on the escalator and I just look at the escalator, it looks like I'm standing still. And that's really all we're talking about here. So what about if I am walking up the escalator? And let's say I'm walking up the escalator at 2 meters per second. And the escalator is going 1 meter per second. So let's see, I'm walking at 2 meters per second. The escalator is going in the same direction at 1 meter per second. So what's my relative velocity? Then my relative velocity is going to be 1 meter per second up and 2 meters per second up. So that's going to be 3 meters per second up. And you have to give a direction because it is a velocity. So it's a vector quantity and you do need to have a direction with that. So let's look at this example. I have Thor on a train, and Thor is moving towards the back of the train at a speed of 2 meters per second, whereas the train is actually moving forward at 20 meters per second. So what I want to know is find Thor's relative velocity. So if Thor is moving forward on the train at 20 meters per second, and he's walking backwards on the train at 2 meters per second, then I'm just going to go ahead and I'm going to just subtract those. And my relative velocity is simply going to be 20 to the west direction because I drew that to the left, and then 2 to the east direction. So that would be negative 18 meters per second. Or you could say 18 meters per second to the west or to the left. And remember, negative velocities just mean the direction. It doesn't mean that I'm actually going slower than 0 meters per second, because you can't go slower than 0 because, you know, 0 stopped, right? I hope that makes sense. If it doesn't, just go ahead and grab me in class and we'll talk about it and I'll give you some more examples.